Nominal is basically you're just grouping things. If I ask you what type of car, the order doesn't matter. You either have an Audi or a Note or a Toyota or something like that, and that's nominal because the order doesn't matter. For ordinal now, if I ask you your your education level, you either have primary, secondary, tertiary. Um, if I ask you what class you're from, you either upper, middle, or lower class. So the order matters. And we, as I said before, nominal and ordinal are both levels of measurement for categorical data. So there is no numerical value that is attached to them. For interval now, there's no true zero for interval. So if I say how many siblings you have, you know for sure that it's ratio because some persons don't have siblings, they're the only child. So it all depends on what the question is asking you. And once you remember the difference between each levels of measurement, you know what the answer is. So now we're going to be doing a question. So it says, use the following to answer questions 5 to 7. It says that a fertilizer company wants to know the average number of acres of sugarcane grown per farm in Jamaica. They divide all farms into 4 classes depending on their size. For each class,
what is going on?
I'm hearing you, the person is talking. Can you mute your camera? Can you mute your mic, please? So from each class, they select So from each class, they select a sample of 5 farms and count and record the number of acres of sugarcane on each selected farm. So which of the following represents the population for this study? So which of the following represents the population for this study? Guys, this is where you guys communicate with me. I know you guys have the answer, but yeah, it's going to be all farms in Jamaica because the question is based on a fertilizer company wants to know the average number of acres of sugarcane grown per farm in Jamaica. So we know that our population is going to be all farms in Jamaica because it says that they divide all farms into 4 classes. And when we know that when we're talking about a population, we always use all. It says now that the response variable for this problem is what? Yeah, so the response variable will be the number of acres of sugarcane grown on a selected farm in Jamaica. Why? Because it says that for each class, they select a sample of 5 farms and count and record the number of acres of sugarcane on each selected farm. And remember that a variable is the characteristic of what is being studied. So we know that in this case, we're studying the response variable would be the number of acres of sugarcane grown on a selected farm in Jamaica. 7 now says, what type of sampling design was used in this study? So was it a simple random, a stratified random sample, a multi-stage random sample, a cluster sample, a voluntary response sample? Yeah, so it was a stratified random sample because they said that they divide all farms into 4 classes depending on their size. Remember that stratify has to do with anything with classifications, type, or anything like that. Once the question asks you for something like that, you know that you're dealing with a stratified random sample. All right, let's look at Unit 2 now, summarizing and describing data. So we're looking at types of graphs. So the first one we're looking at is a bar graph. So a bar graph, each unit can give one answer, multiple answers, or no answer at all. So we normally use a bar graph when we have qualitative data or categorical data, and we have more than one response. So once it speaks about more than one response and it's dealing with some form of grouping, categorical data, you know that you're using a bar graph. And this is how a bar graph looks. Our next type of categorical data graph is a pie chart. So a pie chart, the percent must add up to 100%. Respondents may only give one answer. Slice corresponds to the frequency of each possible response. Sizes of the slices are proportional to the frequency. So a pie chart is used when you want to represent simple, clear information, categorical information in a neat way. We normally use it when we only have one response. So when we were having the guild election the other day, we either chose Gabriel Morris or our president, and you could have used a pie chart to represent how many persons voted for each candidate. So you could use a pie chart to represent how many persons would have voted for Gabriel and how many persons would have voted for CJ. Now we're going to look at graphing for quantitative variables. So we can use a stem and leaf. There are 3 types of stem and leaf. You have the regular stem and leaf, which is what we normally use. You have back-to-back stem and leaf, which is where you can use it to compare 2 different data sets. And then you have split stem and leaf. So using a stem and leaf plot, it's used when data are grouped according to their leading digits. The stem, while listing the final digits, the leaf separately from each number of a class. So we normally use stem and leaf when we're representing data of 20 and less. They have a data set of 20 and less. you can easily represent it in a stem and leaf plot. So your stem here, so these represent your tens, and the leaf normally represents your ones. So if I was to rewrite this out, the first value would just be 5. The second value would be 16. The third value would be 17. The fourth value would be 28, and the last value would be 60. So as I said before, you normally use the stem and leaf when you have a data set of 20 or less. The stem represents your tens, while the leaf represents your ones. The leaves are displayed individually in ascending order after each of the stems. Next, we're going to be looking at the histogram. So the histogram, this is normally used when you have a large data set. So when you have 20 or more, you normally use a histogram. And a histogram, the horizontal axis, continuous range of values for variable, while the vertical axis is the frequency, number, or percentage corresponding to different bins. You realize that there's a difference between the histogram and the bar chart. The histogram, the vertical bars for each bin are touching each other, but for the bar graph, they don't touch. So that's the difference between the bar graph and the histogram. The histogram, as I said, is used when you have a large amount of data, so 20 or more, and so forth. We also have the cumulative frequency ogive. So this is a type of line graph. So there are two types. We have the less than cumulative frequency. It's used to determine how many percentage of responses that are less than a specific value. So how do you know that it's a less than cumulative frequency? It normally starts at 0 and ends at, it's normally 0 and ends. And you know that your less than or more than cumulative frequency is just a sum of your frequency as you move along. Next, we have the more than cumulative frequency ogive. So the more than cumulative frequency ogive is used to determine how many percentage of responses that are more than a specific value. So the more than usually starts at the total and ends at 0. So for the less than, it starts at the left lower value and ends at the right upper value, while for the more than, it usually starts from the left, the highest value to the left, and ends at the lowest value to the right. So you guys can see the difference between a more than and a less than cumulative frequency ogive. And we know that these frequencies are constructed from the frequency distribution. So now let's do a question. So it says that using the following to answer questions 8 to 11, indicate the letter corresponding to the